So today's agenda is yesterday we have in previous session we have discussed about some of the AI problems like tic-tac-toe is one problem we have discussed in the previous session. Also we have discussed about missionaries and cannibals problem. As part of problem solving through AI, we need to learn a lot of things, lot of problem solving strategies. As part of yesterday's session, we have discussed about TikTok toy problem, and there we have applied min-max algorithm. So you have just got some overview that how to apply some algorithm over there. We have not entered into the programmatical part, so because we are not dealing with the lab call sessions here, so we are just trying to understand how a problem need to be analyzed, how a problem need to get some solution. So as part of that, let us take some more time to discuss about some AI problems to get some clear understanding of what actually AI does, how we need to go forward with AI problems. Yeah. So everybody of you might have seen this concept called as Tower of Hanoi in your first year or in your data structures, and many of you have also written your own program for that. I hope many of you have done that. So let's look into this problem. Okay. So today's agenda is like trying to understand two more problems called as uh, Tower of Hanoi problem, and we will try to understand 8 puzzle problem, which will be like a game. Both of them will are again a part of your games where kids will be playing, and you can try to analyze in that manner. And also we will move on to the next topic in our syllabus called as characteristics of problem. Next concept is exhaustive searches, and if possible by end of today's session we will try to go on to heuristic search techniques. So these are the 5 agenda points which we need to cover by today, most probably. Let's first look into the concept called as Tower of Hanoi problem. Okay. Yeah. So before going on to that problem, I just want you to understand what are the various problems which are already solved with respect to your AI problem. So yesterday we have seen TikTok toy problem, missionaries and cannibals problem. Okay, today we will be seeing 8 puzzle problem and Tower of Hanoi. So we are just trying to cover some of the concepts, and remaining concepts are also available as part of your internet. You can just try to Google them, and you need to put some interest, keep some interest, and try to understand these concepts. And also, if possible, try to look at the code of the Python, Java, all the different language codes are available. And because in the upcoming years we may deal with such type of concepts, you need to have a clear understanding on this. That's the reason I have just listed what are the various problems available which are already part of AI solutions. So we are just trying to cover some 4 to 5 concepts, examples with respect to this. Yeah. Okay. Let's move on to the Tower of Hanoi problem. So I hope everybody know what is this problem, right? What is Tower of Hanoi? So here you will be having 3 towers, and you will be having n number of discs of different sizes. Okay. Here you can see a disc of smallest and largest is written here. So we have taken some 3 discs here. Likewise, it can be 5 discs or it can be 10 discs. There will be n number of discs. Okay, the problem is it's a mathematical puzzle where we have 3 rods and n disk. That is, here it's only 3 rods and n disk. It can be 4 or it can be 5. The objective of the puzzle is to move the entire stack to another rod. So all these 3 need to be moved to the last tower, obeying some of the rules. So let's look at what all the rules available. So only one can be moved at a time. That is one rule which we need to follow. Each move consists of taking the upper disk from one of the tasks and placing it on the top of another. That is, here you are having three different disks, right? So the solution, you can see in the picture very clearly what is the beginning condition, what we are having, and what should be the solution. That is what is the objective. And for this, we need to follow these 3 set of rules. And the third rule is no disk may be placed on top of smaller disk. The condition is bigger disk or largest disk should be on the bottom and smaller one should be on top of that. That are the rules. So I hope everybody have now a clear understanding of what is this Tower of Hanoi problem. Let's look at the solution there. Suppose if I take only 2 disks, what should be the solution? So I'll be having rod 1, 2, 3. So as I said, you will be having three towers. Here rod means towers. You will be having three towers. Disk can be 2, 3 or 5, n number of disk can be available. So for example, if you are taking only two disk, first shift disk from A to B. So you are having three rods, A, B and C. So initially we are having all of them into the on A. So we'll try to move A to from A to B, then A to C, and again B to C. So it looks very simple. This is a very simple a kid's problem. What we have solved. But once you are looking at the logic of how to write a program like that, how to implement some step by step procedure, and once number of disks are more, it will be taking a lot of time. Okay, yeah, this is what is the solution what we will do. So the pattern here is first shift, for any it can be 2 disk or it can be 3 disk or it can be 4 disk. Initially we will shift n minus 1 disk from A to B. Suppose if you are having all of them as a stack in A, initially we need to take n minus 1. That is, if you are having n, you take n minus 1 disk from A to B. Next, shift last disk from A to C. That is the condition, because that is the largest one that should be moved from A to C. That is the primary goal, because the largest one should be at the bottom. Again, shift n minus 1 disk from B to C. Okay, that is the condition, because you are having three towers. Initially we will move all disk except the bottom one to the B, and the bottom one will be moved from A to directly C. That is one important logic which we need to follow. Okay, yeah. So we can see a solution for three disk and three towers. A small solution, it's already framed here. Okay, yeah. One second. Yeah, this is a solution which can be followed by for towers of Hanoi problem. Let's look very simple. So likewise, whenever you are having some problem solving, we'll be having 5 different types of things which you need to follow. The terminology, we call it as a terminology as part of your computer science, or it can be AI. So problem solving is a process of general solution from observed data. So if you can look at the previous problem, it is very simple, right? So it's not a much bigger task. It looks very simple. You are having some three towers and three disks. So the problem is very clear here. You need to move all these bundles from A to C in the same manner how it is available previously. For that, you can use a medium called as auxiliary one, which is at the middle one. You can take support of that tower and you can shift it from A to C. So with respect to that, the key elements in a problem solving are initially what is a state. This terminology is very important, because in examinations, whenever they are asking you about problem solving, you need to talk in this perspective. If I say what is a state, or it can be small questions, what are the key elements of problem solving, you need to mention these 5 set of points. That is, what is a state? So a state is a representation of problem at a given moment. So initially I have given a problem, so I am saying that this is the state. That means a representation of a problem. So I'm saying from you need to move from A to C in the same manner. That is what we call as the state. Next, what is state space? Contains all the possible states for a given problem. So here you are using option A as one tower, option B as other tower, option C as other tower. So you need to try to cover this in your area. Next, operators. The available actions performed is called operators. So as I said, because you are having three different sizes, initially I'll try to move first one and second one to auxiliary position, second B, and that is one operation. Next, at the second step, what I'll do, I'll try to move the biggest one, largest one from A to C. Then again, we'll move the smallest one from B to A, and again the median one from B to C. In the same manner, we'll try to do a lot of operations. What are the possible actions we can do? That is one perspective. And we'll be having the initial state and also a final state or a goal state, where you'll be having some solution to your problem. So whenever we are talking about problem solving with respect to your answers, theoretical answer examinations, you need to write in this perspective. Okay, yeah. So as I said, you'll be having we'll be discussing about some new concept called as characteristics of a problem as part of your syllabus. So up to now you have seen what is a problem solving, what are the general problem solving strategies, and now we will move on to the next concept called as characteristics of a problem. So before going on to this, I would like to just keep a small poll. with respect to your towers of Hanoi problem. Okay, read question properly and try to give some answer. Yeah, it's already available. Yeah, make it soon, guys. Answer it soon. Thirty-seven of you answered, and what about remaining people? 13 more need to be answered. Yes, 40 of you answered. I'll just give 5 more seconds. Yeah, I'm ending the poll, guys. Anybody want to answer? Answer it soon. Okay. Uh, just I'll share your results. You can look onto the screen. What are your answers? 29 people have given answer as no, and 12 of you gave answers as yes. So the question is, a typical tower of Hanoi puzzle consists of 3 pegs and 3 circular discs. A peg here is a tower, say a terminology, it can be called as pegs or towers of different sizes stacked on first peg. That is, as we discussed, A, on the A we are having 3 different discs. The goal is to move 3 discs to another empty peg, that is to C. While moving the disc, can you put a larger disc on a smaller one? So definitely answer is no. So people who have answered this as yes, correct yourself, guys. We have in the rules only we have seen. I'll just show the rules again. Give me a minute. Yeah, you can look at the rule 3. No disc may be placed on top of a smaller disc. So on top of smaller disc we cannot keep a bigger one. That is the condition. So one of you asked me to just explain me this again. Let's again discuss about this for 2 more minutes. So here you are having 3 different towers, or you can call it as pegs, and you may have n number of disc. Suppose if I say in the image you can see you are having 3 disc placed here, smaller, medium and bigger one. You need to assume the first tower where you are having disk as A. So I will go on to this solution, it will be better one. So here you can see source, auxiliary tower and also destination. So you need to move all these 3 towers. Wait, one more message. Okay, you need to move all these 3 from source to destination. As part of that, you are having some 3 conditions which we need to follow. According to the conditions only, we need to move the solution, because we cannot take all the pile at once and keep it in C. You need to follow a procedure. You need to initially take first one and second one, the first smallest and medium one, and place in the auxiliary tower. Next, take the third one, the largest one, and keep it in the destination one, so that the base one or the largest one will come at the base. Then initially, then again we will move from the smaller one will be again placed back to A. so that you can move the second one to the final one. As you can see the solution very clearly given in this image. This is how we will try to solve this problem. Okay. So any more confusion guys here? You can just ask me. So can we move forward? You can just say me yes or no so that I can move forward. Guys, is my audio clear? Any disturbances? No responses? Is my audio clear, guys? Okay, okay. Yeah, thank you. Yeah, so we will move on to the next concept called as characteristics of problem. So as part of this only, I'll be trying to explain you the 8 puzzle problem. So whenever you are having a problem, it can be a small game solving problem, it can be a bigger problem, whatsoever it is. Whenever you are having such type of problem, yeah, just give me a minute. Yeah, one of you just asked me this question. Explain me about problem solving. This 5 tasks. Yeah. So here, whenever you are having your problem solving any problem, it can be the. I have showed you some list of 13 examples, the applications of your uh, various problems of AI. So when you are talking about terminology of problem solving, we will be going across these 5 different key elements. We call them as key elements of problem solving. That is, initially we look at the state, that is a representation of a problem. So that is what is actually a problem is called as the state here. So in our tower of Hanoi problem, we have seen that you are having 3 different towers, and that is marked as A, B, and C. You are having some different disk, that is uh, it can be 2 disc or it can be 3 disc. That is what is the problem here. So we are going to represent it as a state here, that is representation of your problem. Next, what is state space? So state space is something like we can draw a tree structure and try to explain what are the possibilities which can be given, or you can draw a graph and say a representation like this is a problem given and these are all the possible solutions what we can see. Like yesterday, I'll just move on to yesterday's slide. Yeah, so here you can see a small tree structure for solution here. If I want to place my next move, I am having 3 different conditions initially. That is what we call it as a state space here. So state space represents a structural notation, or you can say a clear understanding of what are the possible states you can move on. Yeah. And next one is operators here are the available actions which can be performed. Suppose, as I said in the previous problem, because you are having 3 towers, you can use the auxiliary one, which is the middle one, and you can move your disk from one place to other. That's what we call what are the possible actions. And also once the problem is defined, you'll be having what is the initial condition or initial state of the problem, and how a problem need to be addressed. And with respect to that, we will try to go on to the destination. That is uh, one more uh, one more element of your problem solving. So all these 5 elements will be need to be explained properly whenever a problem is given to you. Okay, so hope this is again clear. Number P2. Should I again stress over this one? Okay, so we'll move on to the next this concept, characteristics of problem. So here you can see some 7 different points explained here. First, these 7 different points are very important characteristics of any problem. Keep a note, guys. All these 7 points need to be explained by us in examinations very clearly. So you can expect such type of questions in examinations, like what are the various characteristics of a problem-solving procedure. So you need to now in today's class, I will try to understand all these 7 concepts, 7 different with different examples, and try to understand what are the characteristics of a problem. So whenever a problem is given to us, how do I need to solve that? Okay, yeah. Moving on, for that, first one is the problem decomposable. The first thing what we need to understand is the problem decomposable. That is, can the problem be broken down to smaller problems to be solved independently? So every time we cannot expect a direct solution for a given problem. We need to try to split it into different elements. So we need to have a understanding that in how many ways can I decompose it. Decomposable problems can be solved easily, because as I said in the previous session, whenever you are trying to solve a project, or you are going to give a solution to a problem, you will divide yourself into team members and try to divide a task. That's what we call as decomposable. So whenever you are able to do that, you can submit a solution in time on, and you'll be having some feasible results. So whenever you are trying to address a problem, you need to look whether the problem can be split into further elements or not. If not, then there will be a lot of pressure for us to complete a problem. So for example, you can see a small mathematical example of what is decomposable. So here you are having an integration function of for a given function, and you can decompose it into 3 different ways here and try to do some own separate integration. So in the same manner, in any problem you are going to take, look for the possibilities of decomposing that. That is, in how many ways I can split it into tasks so that I'll be having a effective solution. That's what we need to look into. That is the first characteristics of a problem solving. Yeah, next one, can solution steps be ignored or undone? Because we will be having n number of solution steps, do I need to consider everything, or can I ignore something? Suppose if I say I am having a team of 4 members, I will be having my own idea, rest of the 3 people will be having their own idea. So everybody will be trying to give their own solutions. So do I need to take all the solutions, or can I ignore some? And how do I need to move forward? For example, in theorem proving, a lemma that has been proved can be ignored for next steps, because that is a standard solution or a standard proof which is already available. We need not to reinvent the wheel. We can just blindly follow that, ignore that, and we can go for the next steps. Instead of that, if you are just sitting on that, it will be a waste of time. So whenever you are trying to apply some logic to your concept, to your problem, you need to look into these type of things. You need to ignore some things and move forward, then only solution will be feasible. Or else if you are trying to stick to that, then again it will lead to a lot of misconceptions, and you may not get a proper solution. This is the second point what you need to look into for a problem solving. For example, this is what I want to explain as part of your example, an 8 puzzle game. And also we'll be many of you have played this in your childhood. That is, one of the column will be empty, and you will be given a structure, a small animation picture over there, and you need to or also any image of your hero, whatever it is, you need to put them into a proper structure. That is the concept of your 8 puzzle problem. So you will be having a grid of 9 boxes here, and one will be kept empty. So initially you can see here you are having numbers randomly arranged: 2, 8, 3, 1, 6, 4, 7, space 5. Now the task is, you need to arrange all of them into a proper order, in this order: 1, 2, 3, next 4, 5, 6, 7, 8, and middle one should be kept empty. So you can have different solutions here. It's not only that, here the task is given for us in that manner. So you can use this empty space and try to move up and down and finally get some solution. So moves can be undone and there is a possibility of backtracking. So this is a solution what we need to give by your own choice. This is what we need to understand as part of puzzle solving or as part of game designing. What are the possibilities which can happen? That should be very clear for us whenever you are trying to address any problem. Yeah. So, for example, again, for the same concept, can solution steps be ignored or undone? So, whenever you are playing a chess game, once you are moving a element, what do you call, icon from one place to other, it cannot be moved back. That is because once a step is kept, that is the final step. We should not actually, we should not do it because that is the rule of a game. So, in playing chess, there is no chance of again backtracking until opponent allows you to do that. That is what we call it as irrecoverable. So you need to keep in your mind which are the things which can be recovered and which cannot be irrecoverable, and then only try to develop it in that manner. Yeah. So ignorable problems can be solved using a simple control structure that never backtracks. And next, recover problems can be solved using backtracking. So in 8 puzzle, you have seen you can go for backtracking and get your own solutions. So irrecoverable problems can be solved by recoverable style methods via planning. So we'll look about this in the further sessions. So how this can be done. So once you are trying to understand the concept of problem solving, whenever you're taking some examples, we will try to move on into these steps. So initially, up to now, we need to just have an understanding of what are the characteristics I need to keep in my mind. Then only you can give some solution to your problem. Yeah. So moving on to the next one, is the universe predictable? So every time we make a move in a 8 puzzle game, we know exactly what will happen. Suppose if I am playing that game, if I move from one box to other box, I'll be also having what is next in my mind. So I'll try to expect some certain outcome. In the same manner, you need to have a universal understanding of how this problem can be solved. It's not only in your aspect, you need to also think it universally, like how the solution can be addressed in a number of ways. Then only the problem whatever you're solving will be effective and that will be accepted by everyone. Yeah. So one more example, what as part of your problem solving in AI, that is called as a playing bridge game. We cannot know exactly where all the cards are or what the other players will do on their turns. So you will be you also know this as part of playing cards. Whenever you're playing cards, you don't know what will be the actual move of the person. You can put you some ace card or you can put some king card. Likewise, when you're playing cards also, this is not exactly given solution, right? It depends. That is why we call it as uncertain outcome. So this is example for certain outcome and this is for uncertain outcome. So what if it is a certain outcome and what if it is not an what if it is an uncertain outcome? So for certain outcome problems, planning can be used to generate a sequence of operators that is guaranteed to lead a solution. So in eight puzzle problem, because you are having a determination that I can definitely do this in the order whatever you're asking, because you are having a scope of one step moving up and down, definitely you have your own planning and you will be getting your solution at the end of day. Definitely you will be having a solution. For uncertain outcome problems, a sequence of generated operators can only have a good probability of leading a solution. That is, only some sort of steps can lead to a possible solution. Not every step will be leading you to a solution. So you need to follow some sequence of operations, then only you can expect a good solution and that will be accepted universally, or else that will not be a good task. Okay. Yeah. uh, I'll just again take one more minute and ask you a small poll, so to see how many of you are readily hearing. Okay. Guys, any sort of doubts you can ask me through your chat. I'll be checking out them and I'll try to answer your questions. So if anybody is not following any concept, you can just text me over chat so that I'll be trying to uh, cover those concept again. Yes, I'll be launching poll in just 1 second, guys. Yes, 1 second. 5B9 as me repeat second one once. So what is the second one, guy? Okay. So I'm launching the poll, guys. Just look at the question properly. It's about again Tower of Hanoi problem, and you can give answer properly. So option C is 2 power k plus 1. Option D is 2 power k minus 1. This question is asked because I know everybody of you have learned about this concept called as Tower of Hanoi in your previous years. You need to have understanding of this. "24 only answered. How about others, guys? Make it soon. We need to cover a lot of things. We are having 10 minutes of time. 26 among 44. Okay, it's already 2 minutes for your poll. I'll give 5 more seconds, guys. Make it soon. 35 answered. Yeah, I'm ending the poll. Okay. 36 of you answered. And I got a solutions like 4 different solutions for this question. Yeah. So the answer here is C, 2 power k plus 1. I'll be giving a solution about this in your Google Classroom. In your solution, you can look over there why this is the answer. But for today, we will just try to continue with our class. So many of you gave the answer as wrong. We'll try to discuss about this in the Google Classroom. Okay. I got a question here. Is the universe predictable? Repeat. Okay, sure. We'll repeat it again. Yeah. So we are here only, guys. Yeah. So here in terms of your 8 puzzle problem, as you have seen, what is the problem? So once look at this grid here. So here you are having a problem, like you are having an option of moving one option left or right or down. So solution can be in any number of ways. So if I give this chance to anybody of you to play a game, you will be having your own understanding of your planning. Suppose one of you may move 6 downward first, because here 6 is in the down position. One of you may move 7 to the right or 5 to the left. So likewise you'll be having your own solutions. So what are the solutions you are going to provide with your code or with your logic? That should be a universal acceptable, and the solution also should be in such a manner that everybody will be able to do that. Suppose you have developed a game of 8 puzzle, and if your solution, if I give a solution and that is not accepted by your game, then that is not correct. So the solution, whatever we are going to address, it should be acceptable, universally, and also it should be predictable. Okay, you need to reach to a certain outcome. So as we have talked about some playing cards game, whenever you are playing cards, it can be an online or it can be offline. It's very difficult for us to predict what is the next one we are going to get. It's very difficult for us to exactly expect a certain outcome. That is what is the condition we are discussing here. The outcomes can be a certain or uncertain. If it is a certain problem, it will directly reach to a solution. If it is an uncertain problem, following some sequence of operators, then only it may lead to some solution, or else there is no chance of a proper solution also. That is what is we call as universally predictable. So certain outcomes have a good solution, uncertain outcomes may not have a proper solution. So you need to revise your solutions again based on the feedback provided, and then only it can be again solved. Okay. Moving on for the fourth characteristic, is a good solution absolute or relative? So here you can see some sort of 7 points mentioned here. Forget about what is that. It is about a man called as Marcus. He was a man. He was a Pompeian. Next, he was born in 40 AD. It's a set of sequence of steps given here. And next, you'll be asked a question. So, is Marcus alive? So, taking into consideration of 7 points, we need to give an answer. This is also sort of gaming, which you'll be getting actually in your aptitude. Whenever you are talking about your upcoming aptitude answers, you will be getting such sort of questions, looking at your thinking ability. So what is the solution you need to give here? This actually needs a lot of thinking power, because you need to consider all 7 points and then you need to frame a solution. So here you can see, for the question asked, is Marcus alive? Different reasoning path lead to the answer. So you definitely you'll get an answer in your own style. So as in my understanding, I may say Marcus is alive because he was a Pompeian and he was born in 40 AD. So you can say in your own understanding, because no mortal lives more than 150 years, it may not be alive. That is one understanding. It does not matter which path we follow, at the end we need to get to some solution. That is a solution, whatever you are going to give, is it a good solution or the absolute solution or relative? Solution can be the absolute also. Sometimes you can sit on your solution that this is the perfect answer to my solution. Sometimes you also may have a small confusion that there may be alternative also for this solution. So likewise, a solution can be a good solution, or it can be an absolute one, or it can be relative. Anything but solution need to be obtained. Also the same point, we'll try to look into one more problem called as traveling salesman problem. So to find the shortest path from the place where he's located, he will look into all possible path. So whichever the path which he has, he can cover in less number of time, uh, for shortest path, then it only be selected. But initially we will be at the if you want to get into the destination, you will be having many path. But the problem is you need to have a shortest path with less number of much time should be less. Then only you'll be having a effective solution. Okay, that is what you call it as a absolute one. So you also have possibilities of various different path, but it can be a good solution, but not absolute one. It can be a relative one, because that is also leading to a destination. Okay. Yeah. So any path problems can be solved using your heuristics that suggest good paths to explore. Sometimes for best problem solving procedure, you need to understand exhaustive searches. That's what is the next concept what we will discuss as part of our syllabus. uh, you have also learned about that in the previous years while studying data structures. You have learned about BFS and DFS algorithm. Those are called as your exhaustive searches methods to solve a problem. So that is also part of our understanding, which we'll learn in the next session. Yeah. So next point is, guys, we are running out of time. I'll just move on because you need to attend next class. Yeah. So is a solution a state or a path? So as I said, you need to construct a tree or a graph, or you need to have an understanding of representation of step-by-step procedure to get a solution. You need to follow some state space, or you need to follow some particular path. Then only it will be a effective solution, and it is called as a characteristic of your problem. Yeah. So this is very important point, guys. As I said, because we are training intelligent machines, you're adding intelligence to your machines. You need to acquire a lot of knowledge. Suppose while playing chess, you need to think a lot, apply a lot of your knowledge. Then only you'll be getting a proper solution, or else we will end losing. While reading newspaper, you need to understand what is the summary I can frame. That's what where we understand about natural language processing. So what is the knowledge required to able to get a solution? That is, we'll read the headlines and sometimes we'll try to understand things. The same manner, a machine need to get some solutions from the content given. Yeah. The last point, does a task require human interaction? So if you're playing a game, definitely if you're playing with a computer, because it's a human, it's a computer, a human interaction is necessary. In terms of problem solving, sometimes there is no need of intervention of human beings. So looking into all these 7 different characteristics, we need to get a proper solution to a problem. Okay, thank you guys. You can I'll be just ending the meeting. If any doubts, we'll discuss in tomorrow's session. Thank you.